Okay, hello everyone, welcome. My name is Natan Solnetsky, and I'm a backend developer at Wix.com. And after finishing a 2-year stint in one of Wix's product teams, I was offered to join the effort to migrate to a Bazel build system. And I'm really glad I took that opportunity because it gave me the opportunity to join an amazing task force where we did a lot of research and understand how to do this right, what works, what doesn't work well in this build system. And I gained a lot of infrastructure knowledge, how jars get assembled, how does the class path works, and was able to develop many tools and plugins for the Bazel ecosystem that really allows for increasing the velocity. Sorry. Okay, so a few words about Wix. Wix is a website building platform that allows you to manage your business online. Specifically regarding Wix backend, we have around 250 developers across multiple sites, around 750 microservices, mostly written in Scala, but there is some Node.js as well. And we have thousands of builds every day for quite a complex code base with a lot of interdependencies. And we used to be with building on Maven and running on TeamCity as our CI server. And we suffered quite a lot of slow performance locally for developers' experience, and a lot of wait times in TeamCity as well. Queued, a lot of increase in queue size over time because our scale grew, and it was important for us to keep the dependency tree with floating version, meaning snapshot jars, in order to not get stuck in some kind of version dependency hell. And so we decided, after exploring the field, we decided that we're going to migrate to Bazel and Google Cloud Build. And so with a raise of hand, who here was previously in David Stanky's talk earlier today? Okay, cool. So let me briefly tell you a little bit about the Bazel build system before I get into how you do the migration successfully. So basically, Bazel allows you to build and test any kind of code. It's a generic build platform, and it has a high degree of parallelism. So other than that, you can build a lot of the execution paths here for your dependency graphs in parallel. Another very important feature for Bazel is the ability to utilize the cache where you don't really use any, you don't need to rerun any of the part of the graph that you haven't touched, nor its dependencies. So this, and very accurately. So why is this cache very accurate? That's because you need to define explicitly every input you put into your build unit in order to make it run in the sandbox environment that Bazel has. That means you have reproducible builds, reproducible tests, and you have the confidence that even though not all of your code was rebuilt, you're sure you get the right results. And that you can run all of this locally, but even you can even gain much more performance advantage if you just utilize remote execution. What does that mean? That every single build unit has like one action, an action to compile, an action to run any test, and you can send each one of these actions to be executed remotely on a worker farm. So each action runs on a different worker, and in that way, you're not limited by the amount of cores on your local machine or even on one single CI server machine. And of course, it utilizes the same caching principles, so you can share the cache that was populated with stuff from the remote execution, and just as your local developer, you almost, when you start using it, you don't need to run almost anything if you don't change anything, because you already have all the cache hits from the remote servers. Now, as I said, Bazel is a generic platform. That means that you can extend it for any type of plugin you want for any language. They're called rules. And there are many, many types of rules written by the open source community around Bazel, which is itself an open source tool. So, of course, Java, but also Kotlin and Scala and Groovy and many, many other languages are being supported by Bazel by the community. And one point I would like to stress here is that for each of these rules, you have to define every input, right? So that means that there is, the build files are much more explicit, a bit more verbose, unlike with Maven and Gradle, where you just say, okay, it's convention-based, I have all this source code right here, and do your magic and run it. So there's a trade-off here, but what you gain is impressive performance. So, for instance, you can see here that one Maven local clean build on one of our repositories at Wix backend. So it takes 45 minutes on your local machine. And with just switching over to Bazel and having your local clean run, so there's no cache hit whatsoever, it's already much better performance. And if you utilize the remote cache, so you can see that by using many, many cores on your worker farm, you can get it down to 8.5 minutes just by utilizing the cloud workers. And of course, on the second run of this build, you will get an answer in a few seconds if everything, if Bazel analyzes and see that everything is cached. So these are real results from one of our repositories, and you can see that it's really worth the effort to do the switch. Now, I wouldn't recommend it to a startup that's just getting started. They have an idea and they want to develop it. So they probably want products that are just right out of the box work. I don't have to think about it. Because with Bazel, like I said, they have more explicitness. That means you need to think about how you write the build configuration. So there is work being done on improving this and improving the ecosystem around this, so it's getting better, but you will still have more overhead when you introduce this system, and we'll talk about it, of course, as how Wix did the migration process. So roughly around 100 developers, where you're starting to have like a big graph of dependencies. That means that you're starting to get more and more build, like your velocity is getting hurt. You're starting to witness that running tests really slows you down, and tests are, of course, very important. So I would really recommend trying out and seeing for yourself how Bazel can improve drastically the situation here, like it has for Wix. Okay, so now the main section here is 5 areas that you need to decide on and think about when you want to do a switch like this. So can everyone see this? I hope. Number 1 is you need to think about the granularity of your dependencies, of your build units. So if you use Maven or Gradle, then you have Java or Scala packages or something like that inside one big module, and you tell Maven or Gradle, you put in one configuration file there, and it knows how to scan it and do the build. Now, that's on the one hand. You can take one build file for Bazel with all that configuration and keep it on the module level. On the other hand here, with package granularity, you can break down the build units or targets for a Java package or one Scala package. So then what you can see for performance gains, you can see that if you keep the Maven or Gradle granularity, you will have less improvement in your performance. Why is that? That's because there will be less degree of parallelism because you have less build units to run and they run more consecutively. And also, any small change you do in one of these modules, that means that you have to rerun that module. That means that you have many less cache hits. So of course, for package granularity, bringing it down, you will have much better performance. On the other hand, ease of migration, it will be much more simpler to just use the Maven modules, and you have all the information of the dependencies already inside there. So you just need to encode it to the way Bazel does it, so it's quite a straightforward manner. And also you can introduce this change gradually and have, part of your code in Maven while others is in Bazel because it's easier to interrupt between them. So for package granularity, you will have the situation where you don't have that information in your previous build tool, so that means you will need to figure out for each source file what's the situation with it, what dependencies does it have in other source files. So you'll need a code analysis tool, and you have more configurations to build and maintain. So at Wix, we decided that performance is paramount and key, and we want to do the effort to get it right. So we built an automatic migration tool that we hope to open source. And we used a code analysis tool by a third party. And so it was quite a complex transition period, but it really paid off, as you saw from the performance results I showed you earlier. So this is about choosing granularity. The second thing you need to decide is the amount of source control repositories. So there are a few options here. You can have your entire code base in one big mono-repo, and for that Bazel is optimized for. It's many years the way it was evolutioned in Google. They have one big giant mono-repo. Of course, a lot of developers like to have like each microservice and on its own Git repository. So that introduces some challenges I'll explain shortly. And the middle ground here is to have like a few repositories. So what you can, first I'll explain that with Bazel, so Bazel builds your entire repo and scans and understands what needs to be built and what not. And if you have external repositories, then first of all, it needs to clone them locally using some pointer to that repo, some commit hash. And then it has that source dependency code inside, and it can do it as if it was all one big repository, right, with the source code. So if you think about it and what you need to do here, no matter where you come from, if you look at triggering, for instance. So if you build something in one of your repositories, you need to decide, okay, I want to have all the source dependencies up to date to have a consistent view of what's going on. So so am I going to trigger all the other repository to build and to keep that consistency? So you'll probably have, in the naive approach, a lot of false triggering that you don't really need. On the other hand, with only a few repositories, if you consolidate them, that means you have high interdependence between the repositories, and you won't get any false triggering. Now, about the need to manage the source dependency that I showed you between different repositories. So if you look at a situation with many repositories, that like every few days a new repository pops up, you'll need to keep this list updated, so you'll need tooling for that. And you may suffer performance if you need to clone many repositories at the same time before the build actually starts to compile and test. So that can be a performance issue. On the other hand, if you only have like a few repositories, then you can have a static list of all of the repositories, like let's say that each repository represents some big domain. And that way you have less clones and you can just download the repo as an HTTP archive file, so it's faster. And you'll get better performance here and less complexity. Now, what about Git or GitHub support? So a lot of us like to work on Git. It's become hugely popular in the last few years. And, well, if you have a large code base, you still don't have good performance with Git. So that means that you may require to move to Mercurial as a source control repository. There is active work being done on working on virtual file system. That means that you can get Git in higher scales of code by Microsoft and Facebook and a lot of others in this area, but it's still not there. It's still work in progress to have it openly and widely adopted. So on this front, if you want to use Git at the moment, you probably need, you can't still consolidate all your code to one big repo. So, and working with one big repo has a lot of advantages. At Wix, we decided, we had like 900 repositories at Wix backend, and we decided to consolidate to around 50. And this is working quite nicely with the static list, as I mentioned. But this is still a trade-off. It's still not perfect. So we hope that we will be able to switch over to one big repository the moment that it becomes available, and hopefully that will be soon enough. Okay, so the third thing you want to think about is which CI server you want to run Bazel on, and which remote execution solution to use. So on the one end of the scale, we have open source solutions. On the other hand, you have Google Cloud Build, which is, of course, a commercial tool, commercial system. What about viewing the results of the build? So with Bazel, like I said, it builds your entire repository and understands which bits need to be rebuilt and retested. So there's currently no open source solution to viewing it nicely. And there is, there's no Jenkins plugin or something like that. For Google, they have a product called, in the cloud build called Result Store, where you can see all of the targets built for a single repository, and you can filter the targets according to an area you care about at the moment in your repository. How about custom build flows? So, of course, Jenkins, for instance, which is open source, has a lot of customization possibilities, and you can write Groovy scripts and really highly customize it. So for Google, there's the Google Container Builder, where each build step is run on a different Docker container. Now, it's still, I think, work in progress on achieving the rich environment that Jenkins provides. For instance, a missing feature for Google now is to build multiple steps simultaneously, or deciding to keep the build run even if some step is read. I think that's still not supported. So there's a mixed picture here. Now, what about remote build execution? So there are a few libraries that enable you to do it yourself and run your build farm or build barn where you have your workers on-premise or in the cloud and run it yourself. But I don't think it's still very highly adopted in the industry, so it's still work in progress. Google has a product here called Remote Build Execution that it's in the alpha stage, and Wix has adopted it. And actually, we are very pleased with the way RB worked out, and you can see in the performance before that we really are happy with the results. So as you can see, Wix chose here to use the Google platform. There are missing features here and there, but of course we have the support. We are because we're early adopters, we are in constant communication with Google, and they really improved dramatically in the last couple of months, and I'm sure it will keep getting better as we go along. Okay, so the fourth thing you want to think about is your local developer experience, right? It's very important not only to focus on the CI server. So a few basic options here. Maybe some developers work on Linux and some on Mac, at least at Wix backend. So for Linux, it's quite easy to utilize the remote cache that you have in your remote execution that usually you run remotely on Linux. That's native for Bazel. It's where it's most comfortable. But for Macs, there is there's a difference in the native support here, because if you get an output from Linux run, you probably sometimes won't be able to utilize it for any build you do locally. So that means that Mac doesn't support that and will always be problematic because of the nature of different platforms. So what about compile time? So of course, with Linux, you can utilize the remote cache that you have from remote execution, so it's really fast. On Macs, because you can't, only on the consecutive builds will you gain the performance you want. On the first one, you'll still need to build the entire repository. Okay, running tests in parallel. Again, with Linux, there's great support for testing in isolation and port isolation. With Mac, the situation is not the same, and also the network sandboxing works a little bit differently on Mac, so you may end up with different results on your local Mac and on CI running on Linux. And what about IntelliJ support? And I think other IDEs have Bazel plugins, and it works really quite fine. So as you can see, if you work on Mac, it's not the experience is not that great. So we introduced running Bazel inside Linux in Docker. Now it uses the same image as remote execution, and you can see that there is, of course, improvement in performance where you can take the remote cache and use it and not rebuild on your local machine. On the other hand, synchronizing between Docker and Mac on file mounts there are performance problems there, and sometimes it's not that reliable. You need to reboot it. But this is work in progress on our team. We're looking at different options for file mounting, and hopefully these problems will be resolved soon. And we have a great experience for developers who choose Mac, and they can just run on Docker. Okay, the fifth thing that you need to think about is your third-party dependency resolution. So here, in the JVM, you always depend on something external. It could be Guava, Jackson, many other kinds of libraries. It's a very rich environment. And unlike Maven, where you can have each module potentially depend on different versions, and you can have you can work around and make it work. with Bazel, because it's optimized for one big mono-repo, you have to declare all of your repository, in your repository, all of your external dependencies explicitly. That means that you have to go and fetch all of the transitive dependencies that Guava needs and put them explicitly in your repository. So there is a tool that allows you to do that. It's called the Bazel Dep for the JVM. It just knows how to get all the needed jars. But if you decide to do multiple versions inside one repository for your third party, you'll have trouble utilizing such tools because they work for one version. So it's quite problematic. You have much more manual work to do. And on the other hand, if you do decide to do one version per dependency, that means that you'll need to constantly keep your code up to date with the current APIs that sometimes change when you upgrade the third-party dependencies. So that means that your developers need to maintain it more, but it's really worth it. So at Wix, we decided to stick with this, and in order for everyone to keep gaining the better versions with all the bug fixes, etc. And we not only do it for one repository, we try and do it across all of the repositories for Wix backend. Yeah, so that's on this subject. So you saw all these 5 areas. So what I want to recommend to you is to try it out, and if you do take the right kind of decisions that are good for your organization in this regard, then you can have a very successful migration to Bazel, and you can gain accurate and very, very fast build times for your growing code base that we know we keep writing code, and code is getting bigger and bigger. So you can have that both accurate and speedy build times, and hopefully you'll try it out. So thank you very much. Yeah, so we have a minute and a half for questions. If anybody wants to ask something. Yeah, do we have a microphone?
Hello.
Hi.
Thank you for talk. Can you describe how you decide that you need Bazel but not something else, about process of choosing these frameworks?
Sure. So most of our code, like I said, is written in Scala. So we had the possibility to move to SBT and to, maybe Gradle. When we looked at the landscape and we saw that we want to look not only for this period, and that's sort of like 2 years ago. We want to look in the future. Our code keeps growing. So having these modern tools like Bazel, and there are others in this similar ways like Buck for Facebook and Pants from Twitter, that really give you accurate builds and tests, reproducible, while not compromising with the performance. So if we looked at that landscape, we really thought that Bazel is the best choice for us.
Okay, thank you.
Anyone else? Okay, so I see we're out of time. So thank you very much. And if you want to ask me something in private, so you're welcome to. Thank you.